Can everyone hear me okay? Yeah? Can I just get a show of hands, how many people understand the basics of like what machine learning means? Yeah? Yes? Okay, so that seems like everyone. And how many people here have a design background? Okay, much smaller number. Perfect. Okay, so that's what I planned for my presentation, so that's going to fit out pretty well. So great. Today I'm going to talk about growing user confidence in machine learning products. So we're going to start by talking a little bit about my company that I work at called Tamr. I'll give you a little bit of background so that some of the examples I share make sense. And then talk a little bit about design, get into the meat of how we grow confidence, and then there'll be plenty of time for questions at the end. Okay. So I work at Tamr. It's about an 85-person startup in Harvard Square. We use machine learning to help large enterprise companies rapidly unify and clean their data silos. So we use this through human-guided machine learning. So that machine learning, the big thing to remember is that you need feedback so the machine can learn. So we have subject matter experts, we ask them some questions, we get their feedback, and then we can change their data very quickly at scale. So the key things for us is it's quick, it's at scale, and there's human feedback. I was going to show a quick clip from the video, but we can't get the audio to work, so we're just going to breeze on by. Okay, so here's just a quick example of something that we do at Tamr. So there's this concept of schema mapping where you have all these different files and you want to combine them into one unified schema. And when I say schema, I'm just referring to basically the column headers. So maybe I have lots of different files and I want to unify them into a unified schema with the headers name and zip code. So you can see my first file has a header fn and zip. So as a human, which I am, I promise, I can take first name and say, oh, that probably goes with name, and zip probably goes with zip code. Now this seems really easy to do manually, going on these one-off examples. When you have thousands and thousands and thousands of data sets, you can apply machine learning to this problem. So we can ask for a few feedback, say, where do you think zip should go? And we'll look at the name of the column, the data in the column, any metadata around the column, and then we can automate this process very quickly. But why would our machine suggest that zip goes to zip code? Is it because the title was similar? Is it because the values were similar? How confident is Tamr in the suggestion that zip should go to zip code? So these are some of the questions that can come up when you're designing for a machine learning product. So again, we don't always know why the machine made a decision. We might not know why it said zip should go to zip code. It also can be hard to translate an equation into meaningful thoughts, especially when you're working with your development team. They'll talk about maybe the algorithms or some of the statistical pieces of it, and your end user might not care. Their interest in how machine learning works and their understanding of how machine learning works varies drastically. Great. So let's start talking about how you design for machine learning. We're all about the users as a designer. All I care about is my user. I want them to be happy. I want to empathize with them, enable them, empower them. It is about them. I might have a really cool machine learning product. That doesn't mean my focus is on our machine learning. My job as a designer is to focus on the user. So we go through this life cycle. So the first step is defining the problem. Then you're going to research this problem. And this can be iterative, so as you learn from your research, you might realize that some of your assumptions and hypotheses were incorrect, so then you'll redefine your problem. And then you go into the ideating phase, which is my favorite part. That's when you get to brainstorm all the cool ways you can solve this problem that you've now defined and researched. And from there, you go into prototyping and testing. So we use tools like Sketch and Envision to make prototypes that you can test with users, and then refine the prototype. The next phase is, we call it at Tamr, acceptance criteria, AC. So we'll write acceptance criteria to work with our developers to actually execute the idea that we've designed out and prototyped, and then we go through a creative process to make sure it's behaving as it should. So I want to focus on a few of these bubbles a little bit more because there can be some nuances with machine learning. So first, thinking about research. So generally, why do we research? Understanding our users' experiences help us prioritize how to make updates and which updates to make and how to make them. It's really easy to think that we're our users and just design for us and what we think is interesting, but then you can get caught up in your own biases. So speaking to other people helps us come up with unique opinions and insights that can help enhance our research process and make sure that we're actually designing for the correct solution. So this gets at why it's really good business. You want to make sure you're solving the real problem. A lot of times when you talk to users, they'll suggest a solution, and then when you talk to them more, you'll realize that there's a different problem that they're trying to solve, and you have a better way to solve it. So this gets at researching for machine learning. Number one thing is to determine your user demographic. How well do they understand machine learning? How much do they care about it? Make sure you press your users to dig deeper than a surface level request. So again, like they'll say, oh, I really wish that my product could do this, or I wish it had this feature. You want to push them on that. They're thinking just about themselves, and they might not know what other options are available to them. So dig deep, you want to utilize the 5 whys. 5 whys is this philosophy that you need to ask why 5 times. So you might say, oh, I really want a hamburger today. And I'd ask you why. And you'd say, well, I'm kind of hungry. I might ask you why again. So that's a very basic example, but it's a really, really effective technique to push your user to think about what the problem is. Along those lines, it's really important to also follow up with how they're going to use what they're asking for and ask them to give you more than one example. So they might say, well, I want a hamburger because I'm hungry and, I don't know, Tasty Burger's right next to me. And then if you ask them for more than one example, you might find out, well, they're just craving a hamburger, but there's also a sweet cream right next to them, and then another day they want salad. So what's the real problem? There's a whole bunch of primary research methods. Do you mind if I just like try to swat that fly away? Because
Yeah.
I can see it on the corner of my eye and it's very distracting.
Very annoying.
Okay. It's gonna come back. There's a whole bunch of research methods that we use besides just interviewing people. I'm not going to go into detail on any of these right now because I want to get into how we're growing confidence, but I'm happy to talk about these more. I've given separate presentations on these, so if anyone has questions or wants to see the presentation at another time, just come find me after. Great. So the next phase of the design process is ideating and prototyping. So I think I've emphasized that research is really important, and you should be making sure that you're researching with your target demographic. You also need to make sure you test with your target demographic. Oh, sorry. One more thing before that. Make sure you work with your machine learning experts. So maybe your users that you were talking with brought up a really cool idea for something the product could do, and you want to learn if your machine learning could be applied and feature that in your product. So work closely with your team. Ask them what's possible. Ask them what kind of information you can display about it. Make sure your visualizations are accurate. They should be your best friends. You shouldn't be afraid to talk and work with them. Okay, so this is what I was getting at. Make sure you're testing with your correct set of users. There's been tons of really embarrassing examples in the news about companies not doing this. This is really embarrassing and shameful. Make sure you're testing with a diverse set of people. I was just reading another article just this morning about the soap dispensers also not being able to pick up certain skin tones. So this doesn't just apply for software. Every product you go through a design and research phasing and a testing phasing. You should be doing this. Make sure you're testing and researching with your demographic. Diversity is important. I'm just going to put a quick plug in for that just in general. It's really important. Okay, so another big part of testing is getting feedback. This is, again, you research, you ask for feedback, you test your prototype, you get feedback. And kind of a general BDP, or best developed practice, in machine learning is to continually ask for feedback because you want to always improve your ML. You want it to get better and better and better. So this is an example from Google. You might walk into a restaurant and it'll ask you a yes-or-no question about the atmosphere. I've seen a lot of these. If you're at a gas station, they'll ask if it has a public restroom. It's a really low-touch way to collect feedback from your user. We do this as well at Tamr. So an example for us, this is like a tiny screenshot from our product. And one of the places we apply machine learning is to quickly apply a taxonomy to your data. So maybe I have a taxonomy of different equipment, and I have thousands of records, and I want to know which records are my electronic and precision equipment. So we'll ask users questions, and then they can look through and give feedback. So here we can see that a user has said, yes, Tamr put this taxonomy label on this record, and I agree, I think it's correct. So we can quickly get feedback from our users and incorporate that to put better labels on our data. Trolls. They're not always the cute animated trolls, unfortunately. So users can try to game your system, and this will lead to inaccurate learnings for themselves, inaccurate learnings for other users using your product, decreased confidence then in everyone because it's not working or behaving correctly. People can do this both intentionally and unintentionally. So a simple example of this, I have friends who on their music streaming apps won't say they like a song or will say they don't like a song, which is separate from how they actually feel about that song, but they know that it could change what other song suggestions they receive. So even though that's not reflective of their actual opinion, it's going to affect my results of what songs get suggested to me. So your users might try to figure out how your machine learning is working to then mess with it, or they also might not understand what machine learning is and then unintentionally mess with it as well. We had an instance where a customer didn't understand what Tamr was queuing up for them, and it resulted in them giving really bad feedback. And once we realized this, we were able to correct it and kind of cut that bad feedback loop, but it slowed down the progress of their project because they were giving bad feedback. So here's another example. This is a prototype that is just a mock-up. We were making like a mobile part of Tamr, and we were developing this new concept called Tamr's understanding. So this is going to show how much Tamr has learned from your feedback on this prototype. But we realized that given how we were originally going at it, people are going to want that chart to go up and to the right, like everyone wants all charts to do. But Tamr learns more if you surprise it. So if someone tells me that, I don't know, that back wall is blue instead of white, I'm going to learn a lot more. And if you tell me that it's white and I think it's white, so if Tamr thinks it's correct, I could learn less. So we started to be afraid that people would go back into the product, back into the questions they just answered, and change their answers to change this graph to look more exciting to them. So there were a lot of things we could have done in that situation, is change how we're calculating the understanding, change what kind of visualization we're showing. We ended up moving away from what this prototype was getting at for other reasons. But it was a really interesting example where we're trying to think about how could our users intentionally or unintentionally mess with our system and give incorrect feedback. Any questions so far? We'll have more time for questions at the end, but I want to make sure I haven't lost anyone. Awesome. Okay. Growing confidence. Machine learning is this cool new thing. It's so ambiguous and hazy. How are we going to have our users trust it? How are we going to grow confidence? That's why you're all here. Well, half of why you're here. Half of you are probably here for Kevin. But machine learning is new, but only for now. And we've actually seen this with other products in the past. Other technology disruptors will appear and everyone will be really afraid and not know what to do with it or how to interpret what's happening, and then it kind of becomes old news and we move past it. And the same thing's going to happen with machine learning. So we see an example of this thinking about cars. So when cars first came out, one court of appeals wrote that automobiles are to be classed with ferocious animals. It's really scary and dangerous. They started enforcing regulation and enforcing driver's education and tests, which I am in support of, but this is an example of people being afraid and not knowing how to handle it. And what ended up happening is the American Automobile Association, AAA, became the top supplier of safety information to schools. So they were able to teach children to stay off the streets. So before this, kids would run around in the street, have fun, and play, and then once cars started coming out, they'd get hit by a car. So by AAA kind of taking control of the situation, whether or not you agree if they should or should not have done that, but they were able to change the messaging that was going out there. They also invented the term jaywalking, which flipped it from being their responsibility that you got hit to your responsibility that you got hit. You should not be walking in the street. So there are a bunch of interesting things that happened around cars coming out that made it less scary for everyone to have cars. We're seeing this again. So old technology can become new and scary again. 73% of Americans would be afraid to ride in an autonomous vehicle. This is, we are comfortable with cars. We drive cars all the time, but this new type of car doesn't inspire confidence in us, at least not yet. So should we show how machine learning works? If it's working, you probably don't even think about it. If Netflix is showing you a show that you want to watch, you watch it, you enjoy it. Great. If your music streaming app is giving you songs you like, great. You're probably picking if you like Pandora or Google or Apple or Spotify based on the recommendations it's giving you. So you're picking it based on your experience with the product, but you're not asking it to show you why is it suggesting this song and how is that working, I want to see what's happening behind the black box. You're evaluating the product based on your personal experience with it. What are the songs that are there? So I want you to think about why you're showing a machine learning visualization. Does it have to be about machine learning? Could it be about something else? Can you show an example instead of showing how the whole system's working? You really only need to show enough to give your user confidence. And a lot of times, they don't need to see anything about machine learning. Now, this isn't always true. It is new. People are afraid. There are high-risk industries and products where you do need to show more. So healthcare is a great example of this. You want to trust if a product's telling you that you have cancer, you want to really know that you can trust that, yes, I have cancer, or no, I don't have cancer, which is hopefully what it's telling you. Tamr, we also face some of this since we're working with large scale of data, thousands and thousands, billions of records. When we're applying taxonomy labels to it or schema mapping, our users need to have confidence that's happening correctly because it's too large scale for them to manually check everything, which is why they buy our product. So they need to have confidence that it's working. So what are some common visualizations that we can use? There's a few industry standards that we've seen floating around, and so I'll walk through those, and then I'll talk about some of Tamr's. So there's the decision tree. This is a little more rules-based, but some people still use it for machine learning. So they'll say, should it go to the left or the right at these different decision points? Clustering, this is what happens a lot with the Google Photo app. So maybe my face is that blue circle and someone else's face is the green circle on the bottom right. And then when you get a new picture, you can see, oh yeah, it fits with this kind of clustering of images. That's why it's labeling me as this person. You can also use a random forest classifier. One of the cool things about using a random forest classifier is you kind of like poke at it. So you can measure the feature importance by tracking how the prediction value is impacted by either including or excluding a variable. And then you can see how that affects the different decision trees. And then you can take this result and actually chart the feature importance. And you can see which features are having more of an impact on it. Another kind of similar way to talk about this is think about the relative impact and see which factor is having that bigger impact on your algorithms. There's everyone's favorite, the scatter plot. Industry standard, tried and true for so many different applications. That's kind of the set that I've seen commonly used in the industry to show what is happening for machine learning. So I'm going to run through a few different Tamr examples. So this is an example from our schema mapping. So that was taking all these different files and combining them into one unified schema. So here you could hover on an attribute, and it would show you if it's already mapped to anything in your unified schema, and if it's suggesting you to map to any other attributes in your unified schema. This is a mock-up, it's not real, but this is now in our product. And what I can do here is see, oh, it's suggesting that it should be mapped to location. It's 70% sure, it's 70% similar to location. Do I agree? Do I disagree? So I can hover on a bunch of my input sources and I'll look through their attributes and see if I agree with their suggestions. So through this way, I'm able to build my confidence that Tamr suggestions are correct. Or at least maybe to a certain threshold, they're correct. So we can let you change that threshold and then automate, so anything above, and maybe above, let's say 90%, I want to map to that top suggestion. And so you can bulk map things. So this helps you automate it, and having these like small touch points is helping our user grow confidence. You can also show trends. So thinking about the taxonomy example, where you're taking a taxonomy and applying it to records, we can take different snapshots in time and show that after you're giving feedback and saying, yes, I agree that this record is that equipment, you can see that the confidence in Tamr's labels are going up. So it's much more confident in what it's applying to your data after you've given feedback than before it had any feedback. Words are really important when you're designing these things. Really important. But if I asked all of you to say what confidence means, you'd say something very different than each other. So you have to make sure that you do your research to find out what it is that your graphic is showing and use words that are true to what you're showing. And they need to be true to everyone. So if I'm a data engineer or I'm some stranger off the street that doesn't know anything about machine learning, it needs to be true for both people. We actually have a little info right next to where it says confidence, because we know that words are so important and the meaning behind this graph is so important that you should be able to hover and find out what this means, so you can interpret the graph correctly. So here's an example of something we use internally. This is called a confusion matrix. So we use this when we're looking to see if two records are the same as each other. Are they a match? Are they different? So are they duplicates or unique? And you can see this was a snapshot taken in the very beginning of the process. There's a lot of zeros so far. But you can see how many Tamr's labeled as duplicate, how many Tamr has labeled as unique, and then you, the human, have also started to give feedback on how many are unique and how many are duplicate. And from this information, we can get precision, recall, accuracy, and an F score. This is really valuable when you're trying to like tune your algorithm and make sure it's working. Who is this really valuable to? Did you define your demographic? It's probably not valuable to most people. Why? Because words have meaning. Yes?
Could you talk about the F score?
The F score? Yeah, the F score is a harmonic average of precision and recall. Yeah. I don't know if everyone in this room can define the difference between precision and accuracy, but a lot of users using products just casually on their phone can't. And so if I'm talking about something and I say, this is really precise or this is really accurate, it needs to be true for them to understand it and true so if someone who knows statistics inside and out, it needs to be true for them too. So it's a big part of the reason we use this internally is because a lot of people don't know how to interpret it, and so it's useful for advanced experts. And if you're an advanced user, there is a way to access this in our product, but it's not as helpful as, say, that trend line. We've had long debates over what to call that line. We settled with confidence with a definition, but heated debates if confidence was the right word and what that word means. So I want to take a step back. We've talked about how to design for machine learning. We've talked about why machine learning is new and exciting right now, but it's not new. If you need to show some visualizations for machine learning, we've run through some examples. I've shown you some that Tamr does. But again, machine learning is not some special, shiny thing that makes your product super, super unique. Yes, it might power it to be unique, but for your user, it's a product that's just delivering you songs in a new way, suggesting you a new song instead of you having to choose which songs you put on your app. So you can be applying tools to your machine learning product that other tools use to grow confidence. So I want to take a minute and talk about those. What do other products do to grow confidence that you can do too? The first is a test drive. So So I don't know if anyone else here has ever bought a car, but you give it a test drive. You want to see how it feels. And if you like it, you might buy it. You can do that with machine learning too. You can let people kind of poke at that black box and see if they have confidence and trust in how it's behaving. So if I've trained my black box to classify animals, I might show it a picture of a cat, and it's going to say it's a cat. Great, I'm confident. Let's try another one. Pretty sure that's a dog. My ML says it's a dog. I'm happy with it. That's a dog. I gave it a dog. It knew it was a dog. Okay, I'm feeling really good. I'm getting some questionable faces, but I promise that one is a dog. What is this one? It is a bat, but if I've only trained my ML on dogs and cats, it's probably going to say it's a dog because it looks really close to this dog. So it's important to do your research, make sure you're doing your testing, and letting your user kind of test drive it so they can see what your product can do. So if I've trained it on more than just dogs and cats, it might say correctly that this is a bat. But that having that little interaction with your product is going to help grow some confidence. This is your test drive. Okay, we're coming towards the end. Word of mouth. In the era of Amazon, so I'm going to tentatively call it, you expect everything to have a star rating and comments. I have tons of friends who will not buy anything unless there are star ratings. If it has no star rating, they will not buy it. I think that's a little aggressive, but I understand where they're coming from. It's taken that word of mouth from your friend down the street and your neighbor, and now that we have the internet, it's put it all online. So if no one's recommended it, how do you know that it's good? So you want ratings and reviews. This is why we have so many other things like consumer reports, where if you are buying a car, you're going to read about it, you're going to see the ratings. Same thing with machine learning. It's just like any other product. Have ratings and reviews, have word of mouth. It's really important. If you're an enterprise company like Tamr, we have a lot of word of mouth. Our version, I guess, of ratings and reviews would probably be one of those big industry reports like Gartner. Where do we fall? This affects how well our product does. Okay, so let's talk about the takeaways of what we learned so far today. Research your user. If you're a designer, or if you're not a designer, you should be researching your user. It affects everything we just talked about. I want you to question how much machine learning to show. Is that the correct visualization? Is that why your user doesn't have confidence in your product? It might not be. Beware the troll. They exist. Even if they don't mean to, they do. So think about all the edge cases of how someone could be interacting with your product and what could go wrong, because that's going to affect that individual user's confidence, and it's going to affect the results of everyone else and their confidence in your product. Remember that words have meaning. The words that you use should inspire confidence in your user, and if they're not the correct word, it's going to negate confidence. And then apply testing marketplace practices to your product. Word of mouth is a well-known way to inspire confidence in products. You can apply that here as well.